detached garage fed from a house panel is not considered a separate service. A separate service necessitates its own service entrance and meter, which is not the case when power originates from the main panel. Despite using a 4-conductor feeder including 2 ungrounded conductors, 1 grounded conductor and 1 equipment grounding conductor, a ground rod is indeed required at the detached garage. The grounded conductor, or neutral, in the feeder does not provide an adequate grounding path for the garage. The ground rod establishes a dedicated path to ground for fault currents, ensuring safety. If the panel in the garage houses more than 6 circuits, a main breaker is required. Article 240.15 of the National Electrical Code, or NEC, mandates a main breaker or overcurrent device in panels exceeding 6 circuits. This breaker safeguards the feeder cable and circuits within the garage panel. So to summarize, firstly, it's not a separate service. Secondly, a ground rod is required. Thirdly, a main breaker is needed if there are more than 6 circuits. It's important to know that this interpretation aligns with the 2002 National Electrical Code and subsequent editions. Let's delve deeper into each of these aspects, beginning with the concept of a separate service. A separate service implies a distinct connection to the utility grid, complete with its own metering equipment. Think of it as a mini-service entrance dedicated solely to the garage. This would entail a separate set of service entrance conductors, a meter, and a main disconnect, all independent of the house's electrical system. In the scenario presented, the garage is merely an extension of the house's electrical system powered from the main panel. Therefore, it falls under the same service. Moving on to grounding, the necessity of a ground rod at the garage stems from the principle of creating a lower impedance path for fault currents to return to the source. This path facilitates the rapid operation of overcurrent devices such as circuit breakers, effectively clearing the fault and preventing potential hazards like electric shock or fire. The equipment grounding conductor that's run with the feeder serves to bond metallic enclosures and equipment in the garage, creating an equipotential plane. However, it doesn't provide the primary grounding path required by the NEC. The ground rod, on the other hand, provides that direct connection to earth, ensuring that fault currents have a clear path to dissipate. Installing the ground rod typically involves driving an 8-foot-long copper or copper-clad steel rod into the ground until only a few inches remain above the surface. The rod is then connected to the grounding electrode conductor, which is in turn connected to the grounding bus bar in the garage subpanel. This establishes a solid connection to earth, fulfilling the grounding requirements of the NEC. Now let's address the requirement for a main breaker in the garage panel when more than 6 circuits are present. The National Electrical Code imposes this rule to limit the number of overcurrent devices in a single panel without a main disconnect. The intent is to provide a single point of control for disconnecting all power to the panel, enhancing safety during maintenance or emergencies. Imagine a scenario where multiple circuits in the garage panel are experiencing problems. Without a main breaker, it could be challenging to quickly de-energize the entire panel, potentially exposing someone to electrical hazards. The main breaker acts as a master switch, allowing for immediate shut-off of all power to the garage circuits. It's worth noting that the 6-circuit rule applies to the total number of overcurrent devices, not just the branch circuits. This includes any multi-wire branch circuits, which are counted as multiple circuits. For instance, a 240 volts multi-wire branch circuit would count as 2 circuits towards the 6-circuit limit. If the garage panel exceeds this limit, a main breaker is mandatory. In addition to the main breaker requirement, the National Electrical Code also specifies the ampacity of the feeder conductors supplying the detached garage. The feeder conductors must be sized to carry the anticipated load of the garage, taking into account all connected appliances, lighting, and equipment. A load calculation is typically performed to determine the minimum required ampacity of the feeder conductors. This calculation involves adding up the continuous and non-continuous loads of the garage, applying demand factors where applicable, and ensuring that the conductors are adequately sized to handle the total load. Furthermore, the overcurrent protection for the feeder conductors must be sized appropriately. The overcurrent device, whether it's a circuit breaker or fuse, should protect the conductors from overload and short-circuit conditions. The size of the overcurrent device must not exceed the ampacity of the conductors it protects. It's crucial to consult the National Electrical Code tables and guidelines for proper conductor sizing and overcurrent protection. Improperly sized conductors or overcurrent devices can lead to overheating, insulation damage, and even electrical fires. When running the feeder conductors to the detached garage, it's important to comply with the National Electrical Code requirements for wiring methods. The conductors must be installed in a raceway or cable assembly that is suitable for the environment. For underground installations, conductors must be buried at the appropriate depth and protected from physical damage. When running conductors through walls or floors, proper sleeves and fire-stopping materials must be used to maintain the integrity of the building's fire resistance rating. Remember that local codes and regulations may impose additional requirements beyond the National Electrical Code. It's always a good idea to check with the local building department or electrical inspector to ensure compliance with all applicable codes and standards. They are the final authority in your location. In summary, wiring a detached garage involves careful consideration of several key factors, including grounding, overcurrent protection, and wiring methods. By adhering to the National Electrical Code requirements and consulting with qualified professionals, you can ensure a safe and reliable electrical installation for your detached garage. Let's revisit the 3 key takeaways. Firstly, a detached garage fed from a house panel is not considered a separate service, as it lacks its own independent service entrance and metering. Secondly, despite using a 4-conductor feeder, a ground rod is required at the garage to provide a dedicated path to ground for fault currents. Thirdly, if the garage panel contains more than 6 circuits, a main breaker is mandatory to provide a single point of control for disconnecting power to the panel. These requirements are in place to ensure the safety and reliability of the electrical system in the detached garage, protecting against potential hazards such as electric shock and fire. Now let's expand on the grounding requirements a bit further. The National Electrical Code specifies that the grounding electrode system at the detached garage must consist of a ground rod, but it may also include other grounding electrodes, such as a concrete encased electrode or a ground ring. The choice of grounding electrode depends on site conditions and local requirements. The grounding electrode conductor, which connects the grounding electrode to the grounding bus bar in the garage panel, must be sized according to National Electrical Code Table 250.66. The size of the grounding electrode conductor is based on the size of the service entrance conductors feeding the house. It's important to use the correct size grounding electrode conductor to ensure that it can effectively carry fault currents back to the source. In addition to the grounding electrode system, the National Electrical Code also requires that all metallic enclosures and equipment in the garage be bonded together. This bonding creates an equipotential plane, minimizing the voltage difference between different metallic parts and reducing the risk of electric shock. Bonding is typically accomplished by using bonding jumpers to connect metallic enclosures, conduit, and equipment to the grounding bus bar in the garage panel. The bonding jumpers must be sized according to National Electrical Code Table 250.102. Moving on to the overcurrent protection requirements, the main breaker in the garage panel must have an interrupting rating that is sufficient to handle the available fault current at the panel. The interrupting rating is the maximum amount of current that the breaker can safely interrupt without failing. The available fault current is the amount of current that would flow in a short circuit condition. It's important to determine the available fault current at the garage panel and select a main breaker with an appropriate interrupting rating. The available fault current can be calculated using engineering formulas or determined by consulting with the local utility company. In addition to the main breaker, each branch circuit in the garage panel must also have its own overcurrent protection. Branch circuit overcurrent protection is typically provided by circuit breakers or fuses. The size of the branch circuit overcurrent device must be matched to the ampacity of the branch circuit conductors. The National Electrical Code specifies the maximum allowable overcurrent protection for different sizes of conductors. It's crucial to use the correct size overcurrent device to protect the branch circuit conductors from overload in short circuit conditions. Now, let's discuss the wiring methods that can be used to run the feeder conductors to the detached garage. The National Electrical Code recognizes several different wiring methods for this application, including underground feeder or UF cable, rigid metal conduit or RMC, intermediate metal conduit or IMC, electrical metallic tubing or EMT, and non-metallic conduit or PVC. The choice of wiring method depends on factors such as the environment, the type of soil, and local codes and regulations. Underground feeder or UF cable is a common choice for underground installations. UF cable is a type of cable that is specifically designed for direct burial in the ground. It has a moisture-resistant jacket and is suitable for use in wet locations. When installing UF cable, it must be buried at the appropriate depth, typically 24 inches below grade. Rigid metal conduit or RMC is a heavy-duty conduit that provides excellent protection for conductors. RMC is typically used in areas where the conductors are subject to physical damage. Intermediate metal conduit or IMC is a lighter weight conduit that is similar to RMC. IMC is often used in place of RMC in applications where physical protection is required but weight is a concern. The electrical metallic tubing or EMT is a thin-walled conduit that is commonly used for indoor wiring. EMT is not suitable for direct burial in the ground. Non-metallic conduit or PVC is a plastic conduit that is lightweight and easy to install. PVC is often used for underground installations and is resistant to corrosion. When installing any type of conduit, it's important to follow the National Electrical Code requirements for bending, supporting, and terminating the conduit. Proper installation of conduit is essential for ensuring the safety and reliability of the electrical system. Finally, let's touch on the importance of documentation. It's a good practice to document the electrical installation in the detached garage, including the size and type of conductors, the size and type of overcurrent devices, and the location of the grounding electrode system. This documentation can be helpful for future troubleshooting and maintenance. It can also be useful for insurance purposes. Remember that electrical work can be dangerous. It's always best to consult with a qualified electrician if you have any questions or concerns about wiring a detached garage. A qualified electrician has the knowledge and experience to ensure that the electrical installation is safe and code compliant. To reiterate, firstly, the garage is not a separate service. Secondly, a ground rod is needed. Thirdly, a main breaker is required if there are more than 6 circuits in the garage panel. The 2002 National Electrical Code and later editions support this.